So folks, previously we showed that if you wanted to take the Laplace transform of y prime of t, given that you knew the Laplace transform of y of t was called y sub s, that this would be equal to s y sub s minus y sub 0. So what I'd like to do now, so given, and I guess we're also given the Laplace transform of just y of t we represent as capital Y sub s. So given these two facts, let's go ahead and find the Laplace transform of y double prime of t. Now why is this important? Well, one, it's not too difficult of an extension if we know how to compute this Laplace transform to find this one. But the other thing is then we can take and use the Laplace transform on higher order differential equations like we'll do below here. So we want to find the Laplace transform of y double prime of t. So like always, when you're stuck, you should return to the definition. What was the definition of the Laplace transform? It was the integral from 0 to infinity of y double prime of t e to the minus st dt. And so we're going to find this by doing integration by parts. Let's go ahead and let u equal e to the minus st, which means that du would be minus s e to the minus st dt. Similarly, we'll let dv, differential v, be y double prime of t dt, but that would mean that v is equal to y prime of t. So if we follow the formula for integration by parts, we get the product of u and v, so that's y prime of t e to the minus st, and remember this is then evaluated between 0 and infinity, minus the integral of v, which is y prime of t, v du. So du is minus s times e to the minus st dt. And if we clean that up, we're going to have this limit that we'll take care of in just a minute. What I want to point out right here is that this is going to give me a plus s integral from 0 to infinity of y prime e to the minus st dt, but we already know this is just the Laplace transform of y prime, and we know that the Laplace transform of y prime is this expression right here. So we'll have that in just a minute. The next thing we need to do is we need to be careful with this limit, and as long as y prime is of exponential order, the first term in the evaluating the limits of integration will go to 0 because of this e to the minus s times an arbitrarily large positive t. That'll bring this down for s greater than 0, and as long as this function is of exponential order. So we get 0 minus, and then we would have y prime of 0 times e to the 0 there. So we can rewrite this as minus just y prime of 0, and then here we'll have plus s, and we've already shown that this is the Laplace transform. Let's just identify that. That's the Laplace transform of y prime of t, and we know that that is s times y sub s minus y sub 0. And if I clean up everything here, this is going to give me s squared y sub s minus s y sub 0 minus y prime of 0. And here we have the Laplace transform then of y double prime is this expression here. So in the next video, what we'll do is we'll use that fact to help us use the Laplace transform to solve this second order IVP.